Today we have to stop and consider, where do we get our software from, as a major software package used by many had a breach that was very easy to avoid. We'll talk about this and how Linux does your packages a little bit better. Thanks for checking out this video by Switch to Linux. If you like this type of content, subscribe to the channel if you'd like to see more content like this. With that, we are going to jump right on over to our discussion of how 7Z or 7-zip downloads were turning PCs into proxy nodes. This is an interesting one. Now, of course, we all talk about different software, and you get your computer and then you always want to install extra stuff on top of it. And that really is the principle that we are going to look for. And so what I wanted to mention here is that this is an interesting breach in that the malicious versions of 7-zip here would create these proxy nodes, effectively creating a botnet inside of people's homes. Now, I don't want to focus on the specific how that particular malware happened. I want to talk about how people got infected with it, because it is a very important lesson that you really need to be cautious of. Now, we've talked about before several times on the weekly news roundup, we talked about malvertising campaigns where people would create similar looking sites to real software such as Etcher or 7Z in this case, some instances of Zoom, and then they would appear at the top of the list with advertising. So these guys would literally put together a site and then pay money to Google, who would display the ads. And when you clicked on the ads, you landed on a site that looked like it, and then you basically installed malware. So you always want to know exactly who is the real authoritative source of some piece of software, which may or may not be easy to do. In this case here, this was actually discovered because a person was doing a project that required them to use 7-zip, and he was following a YouTube tutorial which had him walk through going to 7zip.com and downloading the software and installing it. Well, here's the problem. 7zip.com is not owned by the 7-zip project. They use 7zip.org. Now, this is so incredibly dumb. I'm going to call out 7-zip for this. They are such a large, long-running project, and they didn't even think to buy the .com version of their domain. I mean, even McDonald's owns McDonald's.xxx because they don't want french fries and hamburgers to go into places like that, okay? They got it, you redirect it, all right? And that is really the principle. So 7zip.com looks super official, and these guys set up 7zip.com as a mere clone of 7zip.org. They even set up an install file which would install a functioning 7-zip. It just happened to have some malware in the background. They even set up update servers to continuously upgrade your malicious version of 7-zip. They did everything because 7-zip chose not to buy the .com version of their website. That was a rookie move. Now, granted, everybody can make mistakes, and some of these types of things, that one was obvious, but only obvious if you know that 7zip uses .org, not .com. I hope that they buy it, 7zip. I hope that they maybe win a lawsuit against these people, or they go into the domain registration, they demonstrate this has been done, and there is a legal pathway for them to do that, and they can seize that domain, and hopefully they get that and redirect that bad boy right back to their 7zip.org. Okay, but I don't want to yell at them too much, because it is a common thing for people to do some form of domain squatting, typo squatting, or some other form of, ASCII character manipulation in order to make you think you are landing on the right domain. And many large companies have these types of things, which is why these companies sometimes spend thousands of dollars to buy every weird iteration or typo squat version of their name so that people cannot grab them and do malicious things with them. It is certainly a strategy. But what I wanted to mention here is that we have to know where we are getting our software from, and we have to trust that software at its individual source. Now, this is where Linux typically does a much better job. And the reason for this is Linux, they have a couple different ways of doing packages. Now, this is shifting over the course of progression here. But what I want to mention is, first, the majority way most Linux systems do package is having a repository which is vetted and audited, and it is synced together so that most software you need to install on Linux is available. So I'm recording this on Linux Mint, and this is the Linux Mint software manager. Now, the inside of here, we have a number of different software packages from a couple of different sources. So if I do, for example, look for Audacity, which I have Audacity installed over here, and there are a couple different versions of Audacity that we can use. This one here is a system package. There also is a flat pack. This is Tenacity. It's a fork of Audacity. I might actually have my system to only display system packages if it's there. Let me have a brief look at that. I don't remember exactly how I have this set. So show unverified. When an app has multiple formats, it says list all types. So maybe I picked the wrong package there. Let me look at Kdenlive. Okay, so I'm just trying to illustrate that when there's multiple different packages, here you go. Here's an example. So here we have a Kdenlive, the repository version, which is the one I use to edit, and there's also a Flatpak version of it over here. Now, both of these are verified from, in this case, two different sources. But pretty much any software I need is available as either a Flatpak, which is pretty well vetted over on FlatHub. Everything has to go through a lot of auditing before it goes in there. And the other ones are the Linux Mint packages, which is audited well by the Linux Mint team. And then there's just a number of different packages. Hey, if you like stars and want to see where the constellations are, hey, Stellarium is an awesome program, even used by astronomers. Here you can see there's a system package and a FlatHub version of the package as well. So there's a number of different options. So on Linux, you have a much more secure way of installing most forms of packages. Now, this is not perfect, but it does get you a very good step in the way, because, you know, for example, if you're wanting to download some software to do, extraction like 7-zip, well, you just go to the software manager and you search for that, and you will find several different things, although there are really good archive managers installed on many, not all, but many Linux distributions already. So you may not even need to look for anything unless you're looking for specific features. But all that being said, there are ways of grabbing software on Linux that do actually buck this trend, and I want to raise your awareness of these. The first of these that we'll talk about, well, not going there. I completely don't usually do that. So let me jump back on over here. There we are. So this one over here, this is our this one here is the Arch user repository. Now, the Arch user repository itself is a platform that allows you to download software from Arch that has not been vetted by the Arch team. So there's the software that's vetted by Arch. That's in your Arch repositories. There's a community vetted by Arch, and then there's the AUR, which stands for the Arch User Repository. And anyone can add software into this, which means there have been at times critical vulnerabilities discovered in some of the AUR packages. It is rare because Arch people, you're basically, I'm hesitant to find a good example of this, but you're basically throwing a bunch of software code in front of a bunch of software geeks. They spot challenges like this pretty quick. It's very rare to have a malicious Arch user repository file actually infect somebody, because people tend to audit these codes independently and call them out very rapidly when they do. And then the people managing these repositories will get them taken out pretty quickly. But there is not the same type of vetting that is installed, so you can get some malicious stuff into here. Now, a lot of Ubuntu-based distros specifically are going into snaps, and a problem that I'd recognized with snaps a long time ago, because the snap store kind of duplicated what the Windows store was in its earlier iterations, full of abandonware, full of a lot of weird software from a lot of weird developers, and a lot of these things are still in the snap store. And in this case, what Alan Pope, who was a person who worked on snaps before. He was a community representative for, or a PR person for Snapcraft before he went out to doing other things. Now he's actually raising a little bit of awareness. It's kind of funny. He used to spar with me on the internet all the time, and it turns out that now we've joined the sides. I have cookies on my side, so he just couldn't resist. But anyway, what he's mentioning here is, as snaps have become abandoned and people have let the domains go, squatters will pick up those domains, revalidate, and push malicious software into the Snap store. And since snaps automatically update themselves, you'd get malware installed automatically. This is the reason why I do not run snaps unless I have no other choice of software. I will always go to the repository first. If that fails, I will look at a Flatpak. If that fails, I will look at an app image. If that fails, I will look to see if there is just a binary download that I can do and install. And if that fails, well, I'll go to the Snap store if I absolutely have to. But the point I wanted to make here is that your software on Linux, if you use the basic built-in repositories, except maybe the Snap store, you are generally going to have code that is a lot better chance of not being malicious. Not perfect, because supply chain breaches can happen, but you have a lot better chance because it's audited. It's not coming in randomly. It is code that is, in theory, going to work with your system, outside of, as I said, the Snap store situation here. But what I wanted to mention is, one of the problems with a lot of your Windows software is you got to go out onto the internet a lot. And if you're not very careful, you could end up going to a malicious site and downloading what generally would be a good program that becomes malicious over time, or what you think is the good version of the program, but it's actually a malicious lookalike. And so you have to be very careful to trust your software and make sure that whatever you're doing, be confident of what you have before you install anything. Linux generally makes this a lot easier, particularly if you're using the repositories for installing things. Flatpaks are generally a little bit more safe than snaps. Snaps generally are pretty safe, but there are some warnings with it that we have seen in recent years. And then there's app images. I think app images could have a potential to be malicious as well, because there's no really centralized place where they're all audited. They're kind of like the Windows software of the Linux world. You just go on the internet and find them and download them. So they're not generally, certainly not audited as much as they could be. So you have to be careful with that as well. Just the overall iterated point here: trust your software, be aware of what you're downloading before you download it. So let me know your thoughts about all that in the comments down below. Thanks for watching, and I hope that you enjoy switching to Linux.